Hi, everybody, and welcome to this Deephaven talk on the C++ client. My name is Corey Kosak, and I'm here with my colleague, Cristian Ferretti.
Hello.
So what we'll do is we're going to present a series of episodes that present interfacing to Deephaven in a sequence of increasing complexity. And in this first installment, we're just going to deal with very simple examples, kind of a hello world thing, where we are going to create static data in Deephaven, and we are going to access it from the C++ client. So let's get started. So here in this window behind me, I have the Deephaven console, and I'm going to create just a very simple table. I'm going to create a static table of 10 rows with an integer column and a double column in it, with the twist that the double column is going to have a few nulls in it. And that's going to be kind of the base table that all of our C++ code is going to access. So I'm in the Python context, so I'm going to import the empty table command into Python, and then I'm going to create this table. All right, so this is our first simple table, and this is the data that we're going to be accessing from the C++ client. You can see the integers going from 0 through 9, and then these kind of square roots on the right, which are doubles. But the way our expression was written, we clearly have nulls in the positions that are like, at mod 3 equals 0. So 0, 3, 6, and 9 are null. So we've got a few special kind of reserved keywords in they're really kind of reserved meta variables in Deephaven that kind of help, especially when you're creating a kind of synthetic table like this. I and II are these index variables. I is the integer version, and II is the long version, and they are literally just the kind of increasing numeric row ID of the table. And you don't use them a lot, but you use them. There are cases where maybe you're creating synthetic data like this, and you really just need a quick and dirty row ID, and that's what you get with I and II.
So we're essentially creating a table with 10 rows, right? With empty table of 10, and then doing an update so that on each one of the rows, we are adding these two columns in 64 value and double value. That's Deephaven query syntax, in case you guys are not too familiar with that. But we're naming the columns, and then we're doing an assignment to them. So there, we have that little table with 10 rows there.
And so what I'm going to do now is I'm going to switch over to my C++ IDE. And here I've written, you can see on the screen, I've written kind of a program like you might have written if you're programming the Apple II. I have I'm printing a main menu to the console, and I'm allowing people to choose, like the person running the program, which in this case is us, to choose kind of which option they want to run. And so what I'm first going to show is just how you would access the table and print it out on your screen. And that is this code here. And it's, like very simple. As it happens, the library has built-in ability to stream tables to an O stream. And so this code there's just not much there. Let me step back a little bit. The way this started was I had to indicate a host and a port where my Deephaven server was running. I connected to that hosting port. I get a so-called table handle manager, which is basically the main library entry point that gives you access to all the Deephaven features. And then I pass that to one of a variety of utility methods that that do the various steps in today's demo. So the first one is literally, just print to the string, and then let's run that. I'm going to click run here in my IDE. I'm going to get my main menu. I actually have programmed an Apple II, so this is very familiar to me. Print static table, and look, there it is. So easy peasy.
So essentially just getting static data from the table that is in the Deephaven server, in the client, we're connecting, we're getting the data, we're showing it on the screen with std out, right?
Exactly. And the more useful example is, well, I don't want to just print data. I actually want to fetch data from the server and kind of process it. So our next demo is called with Arrow. And here we're actually doing, we're using the Arrow Flight Client API. I've added another question for the user because we're gonna break this next demo into two parts. Null the code that handles null and the code that doesn't handle null. Just because null handling an arrow is slightly interesting, so we're going to break that. We're going to break that apart. And this code does something similar. It fetches the table. It asks the user whether they want the null-aware version, and then they print the table. Now this is code that we wrote, and this is quite a bit more. This is quite a bit more detailed than before because we are actually going to Arrow. I'm going to hide the console for a second here. We're actually going to Arrow and using the Arrow API to get the data. And, we might not be just printing it. We might be processing it numerically or whatever. But the steps here that are involved is this is the step that goes from a kind of a Deephaven table handle back to an Arrow flight stream reader. And that's straight from the Arrow flight client. So we get the flight stream reader, and then there's going to be a big loop where we read the data back in chunks. This flight stream reader next is going to read the first chunk. We have a little bit of, because we want to be careful about checking for errors, and because checking for errors can be kind of verbose, we have a little bit of helper method stuff here. So that's what this is all ceremony having to do with checking for errors. And this is the logic that's actually happening. So we ask for the next chunk. If it's the end, we break out of the while loop. And then here we've kind of hard-coded the values we expect to get. In other dynamic scenarios, you're not going to know the types. You're going to have to kind of query the schema to find out the types. You have to find out how many columns there are. You're going to have to find out the types of those columns. But in this case, for the sake of exposition, we're going to just use hard-coded values. So our first column, get column by name, same kind of error checking. If it's null, then we also happen to know their types, and these are built-in arrow types. We happen to know that the first column is going to be the data is going to be of the form of an int64 array. The second one, the data is going to be of the form of an arrow double array. And we also check that those dynamic casts happen to succeed. And then here's kind of the meat of the code. Because I didn't want to write this thing twice, I have this null aware flag. The simple version of the null aware flag just uses, we're going to iterate over the arrays. We're going to get their value with this arrow entry point called value, and then we're going to print out what we got. So maybe at that point we will run and see what we get. And I think what you will see is that it's kind of the same values as before, except in the case of nulls, we got these very special kind of weird looking floating point values.
Which is the marker that Deephaven uses for a null double, right?
Yeah, and so this is probably worth a tangent into that discussion. In the Deephaven system, all of our numeric types we kind of reserve one special reserve value. We kind of steal it from the range, and we use that as an indicator for null. And this allows us to have a null value without using any kind of extra storage. But it does mean that for every numeric type, int, short,
we have to steal.
Yeah, exactly. There's one number that you can't use, and so you have two choices when you're using arrow, because arrow also has this very structured way where you can ask whether an element is null or not. And typically, I would say, or maybe more commonly, in arrow, what you do is you first interrogate the data structure, and you're like, oh, is element X a null or not? And then if it is, it's null. If it's not, then you go look at the value. You kind of do two queries.
Conceptually, you can think that each column has kind of like a Boolean array for whether the values are null or not. Something that is relatively, somewhat interesting, I guess, is that what value is there from the point of view of arrow if the Boolean array indicates that it is null. When it is null, the value that is there from the point of view of arrow is irrelevant, which allows us to do this compatibility thing with Deephaven because we're still sending our own notion of null there, but arrow doesn't care.
Yeah, that's right. And this also comes into play because there are a couple types like string. And string is a value type in C++, and bool doesn't really have a value you can steal because if you there's only two. And so in that case, programmers pretty much have to use the arrow approach. There's no like special Deephaven test for null. Let me go to what the code is when you are null aware. There's a step that I skipped where I just explained that the way you access data from an array is you first call is null, and then you can get the value. But there's also kind of a way to get both pieces of information in one call, and that's the indexing operator. And that returns basically an optional of t, whether it's an optional of int or an optional of double, where you can say, does the optional have a value or not? I probably should have written this out a little more verbosely because there's a lot going on here. But because what I did was I wrote kind of an OStream adapter, which is basically allowing me to print out those optionals in a compact way. So I think in order to make this make sense, let's go look at that code for a second. Basically, all the magic is happening in this little print routine. This little so-called OStream adapter is holding a reference to the actual arrow optional, and it's literally kind of querying it. If the optional doesn't have a value, it's printing null. If it does have a value, it's dereferencing the optional and getting the underlying value. Now, I'll put a different string here, real null, just to kind of show that this is, and I can kind of print whatever I want. So if we run the same demo, we were doing with arrow, yes, null aware, and right. So now,
really null. One thing that we're fetching data by column blocks from Arrowflight, right? And printing the data by row. So, I mean, it's kind of obvious that you have a for loop in there inside the while loop that is getting the columns, and we're getting both columns just to make it explicit. We're doing this kind of transformation, right? From columnar data, which is the efficient way to fetch data, we're printing it by row for the purpose of, this little demo.
All right.
Cool. So we're in number 2, right?
I wanted to kind of demonstrate a little bit of how you could add interactivity to a client. And that is, with a little bit of user interaction, you could modify the query you're doing rather than doing a fixed query. And so the idea here, and this is very toy by the example, but it's like, imagine that the user is allowed to limit the number of rows that they see by typing in kind of the max ID number. Basically, I want to construct a where clause that looks like where in 64 value is less than limit, whatever the user typed in. Let's go back to the Deephaven console for just a second. Filtered equals demo1 where int 64 value is less than 3. This is the behavior I'm going for. Basically, I took the existing table, I created a new table called filtered. Going back to our code, I kind of want to simulate the same thing that might happen in C++ code. And in the first version of it, I'm going to do the kind of low-tech way where I literally construct the string. I'm literally going to construct this exact string as a string and pass it to the server. So interactive where clause 1, enter limit 3. So here, it's printed out the little string that it's created, and here's the output.
Something that is interesting, right, from the C++ code there is that if we compare the code that you write in C++ and the code that you write in the console, essentially you have this table object in the console and you say .where and you pass the filter as an expression in a string. The C++ code is the same, right? In Deephaven, we say that we have this table API, right? And table objects have an API with different methods like where, sort, etc. So the implementation of the C++ client makes those same methods available in C++ from the client side.
And I think we could go to interactive where clause too. And I think the observation here is like, well, you really don't want to be constructing strings. It can be kind of, it's a programming challenge. It can be kind of annoying, and it's pretty easy to miss a parenthesis or just have things kind of messed up getting the syntax right. So what we also have in the C++ client is kind of a so-called fluent interface where we actually use operator overloading and other techniques to construct these expressions on the client side. And that's takes a bit of explaining, but let's show what's going on here. We have the table like we did before. What we do here, this is kind of new. We create this variable int call, which is kind of a C++ sort of placeholder representation for that column. But it gets used in a context where it participates in this kind of fluent language, in this operator overloading. And so what I mean by that is here I have a C++ expression, int call is less than limit. Now that is not evaluated, by the program. That is captured as a kind of syntax tree, and it's sent to the server. So how is that possible? Well, int call is this kind of very special kind of placeholder type. Less than is going to be an overloaded C++ operator, and limit is like literally a int64. And so the compiler is going to see this expression. It's going to call a library method that basically returns basically an abstract syntax tree type, and that's the thing that's sent to where and evaluated in the server. Now, the advantage of that is that you can't make a mistake. If you said int call, I don't know, less than greater than limit, which works in BASIC, but it's not valid C++, you immediately get so C++ thinks that's a template. If it's not syntactically correct, you can't even compile your program. So when your expressions get kind of interesting, you might have int call, limit, and price greater than 12.0, whatever, 12.5, and volume times price less than 1 million. Like once you start constructing, this is highly speculative, but once you start constructing sort of interesting expressions on the C++ side, you get kind of grateful that you have this fluent language helping you out. Okay, we're still running, so I'll just do interactive where clause 2, limit 4, let's say, and it gets the kind of data you expect. I want to kind of emphasize that we have the full table API implemented in C++. So, you could even be like order, where's my sort?
Your IDE is giving you completions there for things that you can type. That's interesting.
Yeah, that's, so sort, oh boy, I think I can say int call descending. Oh, maybe I have to do this. Okay. Right. So sort takes a list of columns and whether they're ascending or descending, and in this kind of relatively compact sequence, I can do the same thing, but sort them, and let's see if that actually works. I don't really want to limit it because I want to see them all. I'll say limit 10. Look.
There you go. Yeah.
All right. That is actually the end of chapter 1. Cristian, did you have any comments, or do we have any?
I think it would make sense to kind of like summarize what we saw, right? Just to ensure that we are all understanding the same here. So we have a table defined in the server. We have a client, another program running separate from the server, different process, right? Connecting to the server, getting the data, right? And we also have that client with the ability to, referencing that table on the server, request the server to do table API operations like filtering with where, like sorting, and sending the result to the client, right? And Corey also explained some differences in our null handling and the options that you have there, with some code for C++ in terms of optionals, And also he explained our more fluent API using, C++ operator overloading and other tricks, so that you don't have to use strings for the expressions that you hand over to our table API.
In chapter 2, what I anticipate we would talk about is dynamic tables, which are kind of the bread and butter of Deephaven anyway. Streaming tables that change, and how you write a C++ client that can keep up with and stay in sync with a server with a table, which is like the data is kind of winking and
changing, moving
in all kinds of interesting ways. So stay tuned, and we'll see you in chapter 2.
Thank you, everybody.
All right, thank you.